now so we can see everybody. Hey, Buck. Hey, Anthony.
Hey, how you doing, guys?
Uh-oh. You're not giving me audio, Buck. I don't know why. Let's get you some audio back.
I'm not giving you audio. Can you hear me?
How come I cannot hear you? Something
Okay.
is up. Oh, I'm soloing you. That's why. How about now?
Hi, guys.
Hey, there we go. Got the audio worked out. Every once in a while, I have a couple of issues with getting this new technology to work on a brand new laptop. By the way, everybody, I'm sporting a brand new BIMBOX in front of me. This show today is brought to you by the BIMBOX laptop. So we're going to be talking about some processors. We're going to be talking about how processors, specifically that CPU, how it affects your modeling in BIM, and the important things you need to know about that CPU. Before we get going too far into that, though, I want to bring something to your attention. Let's just pull this up here real quick. Midwest University is an event that's held here in the Midwest, of course, because hence the name, right? It's in Minnesota, March 20th and 21st. The sign-up time is coming to a pretty quick close here, so if you haven't signed up for this yet and you think this might be an event you want to go to, sign up now, man. Get in there. It's a great event. Buck's going to be there. I'm going to be there. We're going to try and get Anthony there. We'll see if his schedule works out. So if you wanted to come say hi and ask us questions in person after you've watched this series, by all means, show up for the Midwest University event. Let's see, Buck, are you teaching a class there? I thought I saw you teaching a class.
Yeah, we're gonna be doing kind of an in-depth, similar to what we're doing here, but a deeper dive and answers to questions, letting people kind of bring up some of the hardware issues they're coming into, but mainly just talking about BIM workstations.
Excellent, excellent. Hey, Rob, how's it going? I see Rob Becker Bower just put in a hello everyone there in the chat stream. So what's up, Rob? Looking forward to seeing you there. I know you'll be teaching too this year, I believe. So we'll see Rob there as well. All right. We may as well talk about something that we ended the last show with. We did a drawing for a, what was it, a RAID drive, right? That's what you were offering up. In fact, I think you've got it there in front of you. Yep, that guy. So it's a triple solid state RAM drive, or a hard drive there. That thing is ridiculous. It's great. Is it 3 or 4 slots?
It's 4 slots. So we have 4 NVMe drives right here. Oh, excuse me, on the other side. I'm looking at it backwards. And one of the interesting things about this one is if you see this little metal piece right here, finally found it. That's a PLX switch. So this is actually an X16 RAID drive, which means we get full bandwidth through to the CPU.
That is amazing. So, if you guys, we already did the drawing for this. We're going to be announcing who this is in the next BIM broadcast. Buck and I have to compare notes on who we had DMing us based on the last drawing. So we'll compare some notes, and in the beginning of the next show, we're going to announce show number 3 of this series. We're going to be announcing who wins that. But for today, we're talking about processors. And Anthony and Buck, you guys are really the experts on this. I'm kind of along for the ride to listen and learn like the rest of our audience. So I'm going to play the question asker in a lot of cases and try and figure out this information about processors today. Sound good?
Perfect.
Perfect.
All right. So in our last show, we said one of the most important things about your computer, if you could pick one thing to help improve, obviously it's a full system, but if you could pick the one thing, Anthony, you said that CPU is probably the most critical focal point of your workflow, right?
Correct, yeah. I agree with that completely.
All right, so let's talk about the processor, because if it's that critical, obviously picking the right one is really meaningful. So what are we looking for? Just give me the high level overview. What are you looking for in a processor?
I mean, for most workstation workloads, like an AEC, Revit, literally just comes down to clock speed. You want the most clock speed you can get, and typically, if you just shopped on clock speed, typically the better processors within a lineup will have the higher clock speeds. The i5s have lower clock speeds than the i7s, and the i9 in the small chipset will have a higher clock speed than the i7 as well. So clock speed's my thing right there.
So from the
very high level
point of view, from the Intel point of view, the I number, i5, i7, i9, that determines your kind of like floor of your clock speed, right?
And well, it comes down to cores, but if you get the best CPU in each category, i5, i7, i9, well, the i9 naming is a little tricky now, but typically the i7s will have a higher clock speed than the i5s if you're looking at the same, the highest end i5 versus the highest end i7.
Right. Now, you're talking Intel at this point. Now, Buck, close your ears, plug your ears for a minute, because I'm going to mention something you're not going to like. There's other manufacturers out there, right? There's AMD, and I know, Anthony, you've done some interesting work with AMD and their processors. Since they are definitely a factor in the market, tell me a bit about them and their clock speeds and what we would look for on their architecture.
Yeah, AMD's tricky. Like, they've been irrelevant for many years, and then all of a sudden, when they released their Ryzen, line of CPUs, they've really become something you got to think about. For Revit specifically, they just don't have the clock speed. But where AMD shines, they're providing a lot of cores at a good price, and but the thing they have against them is just the clock speed's not there. I mean, sometimes you're looking at like a 1 gigahertz difference between Intel and AMD, and that's something you could genuinely feel in Revit specifically. I mean, in RFO, it could be like a 40-second difference in a benchmark.
Right, right. By the way, speaking of benchmarks, we mentioned benchmarks heavily last week as well, or last time we met as well. We have 3 BIMBOX workstations in the office right now. The laptop that I'm using here, and there's 2 other desktop versions of this. There's a Striker and a Raptor. Oh my gosh, those things are sick. They are amazing. The Striker, I believe it was, scored a 78 on its model creation time, on its standard. My goodness, that was unbelievable. This laptop scored a 90 something, low 90s, and the Raptor, I think, was in the high 90s to low 100s. But man, that was impressive. It was crazy.
And that's a perfect example of clock speed right there. Right. That Raptor had, I don't remember if we sent you a 14-core one, but its peak boost is 4.5 gigahertz. You got, let's say you had the 14-core unit. It might have been the 18-core. I'm not sure. That's just a sheer clock speed, even though the CPU is, maybe like 3 times as much money, you know?
Right. But yeah, it just screamed through those benchmark tests. It was great. We haven't run the extended test on them yet, but we're going to be doing that soon, just to kind of get a benchmark of the extended as well.
And this is a great example, Shawn. I mean, Anthony will probably get upset with me when I tell you, Anthony, the Striker we sent them is the 886, not the 9900K, just due to the availability to getting them at this time. So, Shawn, that's already a dated processor as far as where we are now. One of the things that really gives that processor is the delidding process, which Anthony brought to us. These things go really fast, and this is why I just want to touch back on the AMD. I personally love AMD. They keep Intel honest. Anytime you have a monopoly in the market, the only way to get better performance and price down is to have a competitor, right? And if Intel didn't have a competitor, I don't think we'd be seeing the high core count CPUs come out for a long time. The i7, i9s, it was a 10-core cap. And then all of a sudden Ryzen came out with these 18-core and 36-core processors. And now Intel's been forced to release 18 and 28-core CPUs that my speculation they had on the shelf for the past 2 years, and just why beat yourself, right? Why put out a better product than what you already have? I mean, what are you doing for yourself? But one of the things that happens with those AMDs is they get extremely hot, especially if you start trying to go fast with them. And that's one of the things that we always try to mitigate. In a professional workstation that someone's going to be running 8 hours a day, even if we can make it go fast for 15 minutes, that's not going to do you much good over the course of 8 hours, right? The whole goal is to keep it cool. So just to touch on that, that's one of the things that really separates the Striker that y'all have is the delidding process, where we actually took off the heat sink sent to us by Intel and put on a full copper jacket, which is just much more efficient on cooling.
Yep, absolutely. So that's actually something that when you sent me a text, Buck, and you gave me the specs of this laptop you were sending over, and you sent in that little piece of note, that little note about delidded. And that was it. I mean, it wasn't new, but it was new enough that I was like, what the heck does this mean? What's deleted? I wasn't sure what it meant because I read it wrong in my head. And my developer sitting next to me goes, you mean delidded? And I went, oh, now I get it. So tell me, explain this again, delidding. You're taking off, so when you get a processor, normally you get a little chip and it's got the little metal shield over it, not the full heat sink, but the metal shield. That's the lid you're removing, right?
Right. So basically, it's been a few generations now since Ivy Bridge or like the 3000 series. Intel switched to using thermal paste rather than solder to join the IHS, the integrated heat spreader. That's that metal part.
Yep.
They've been using a thermal paste compound to join that to the die, and it just doesn't cool as good as solder. So basically, we're fixing that. Yeah, we're getting sometimes like 20 degrees Celsius drops in temperatures by doing the delid process.
And the key about this, just to kind of clarify the delidding and why you're doing this, again, like you said, you got to keep these things cool. Extreme heats are the enemy of processors. You get hot,
right?
It starts to not to perform at optimum levels. So you guys are pulling that stock Intel heat shield off, putting a custom heat shield on it, a better matched heat shield over that, and you're liquid cooling these things.
Correct. Thankfully, though, I think with pressure from AMD and just the density that we're getting, Intel's starting to use solder again. So, you know, I'm happy from a manufacturing standpoint. But there may be a few models where we're talking about where we could still delid it and get some gains. It's just something Buck and I are going to be discussing whether we continue, just because thankfully, I mean, they're starting to use solder again.
Right.
Well, and just to chime in, Shawn, the laptop that you have right now has a delid processor in it. Anthony almost killed me. He sent me this awesome demo workstation. And I was like, maybe we just, because laptops, the hardest thing to do is to cool them. You can't put liquid cooling on. They're really small form factor. They get hot. The GPU's in there, the CPU's in there, everything, and there's just not a lot of airflow. So I ripped a CPU out of a perfectly good, overclocked, perfectly tuned computer against Anthony's wishes and threw it in that laptop to see what we could do. Because, to really get the best performance, you got to mitigate heat. So you have one of the only delidded processors in a laptop that I know of right now.
Woo! Rock
on, oh man, I know I know I'm gonna have some cleanup to do later on after with the striker.
Right.
Yep.
But yeah, so this, just speaking about this body of this laptop that you guys sent over, I probably shouldn't talk much about it because it's not one that I think you guys actually are like marketing, but this thing has some ridiculous airflow at the bottom. It is wide open. I was impressed.
It is. One of the reasons when we were kind of getting crazy on overclocking and seeing how far we could push a mobile workstation or a laptop, was to get a big chassis with as many fans as possible and just see if we could actually get it to hit that 5 gigahertz. And unfortunately, in the laptop, the boost happens so quick and the heat's already there. I mean, just turning it on creates a lot of heat. But that laptop right there is a kind of, I'd say, a hack away at trying to make a desktop out of a laptop. It's a custom one of, and we weren't getting that much better performance than the other smaller ones, so that's why we kind of scrapped it. But now you get a great laptop.
Understood. No,
I think Buck touched on an important issue: the marketing between boost clock speeds and base clock speeds and all this terminology you see around Intel.
Yep.
That I'll quickly just say AMD is a lot more honest or a lot more realistic with their advertised clock speeds, but to get your peak boost, and Intel stopped releasing the table. So meaning like you might need one core workload to get your full 4.8 gigahertz, and then 2 cores might drop down to 4.6. But it's also looking at temperatures and how much power consumption the CPU's actually using.
Right.
So doing a manual overclock we have complete control over all that, how that functions. So just because you see Intel market a 5 gigahertz CPU like the 9900K, that's only that might be 2 core workload, but it's realistic out of the box, out of the factory. you might be like 4.7, 4.8 gigahertz realistic clock speed. And if you're rendering all day, that drops down to, I think it's like 4 or 4.3 gigahertz.
Right.
So that's something to be mindful of when you see clock speeds advertised from Intel.
And I think that's an important note as well. When we're talking clock speeds here, Revit itself and Civil 3D and a number of the other platforms that are out there for design, most of those are single core. So you're not able to use the full range of all of the 18 cores or however many cores you have. You're using a single core. You're limited by that, right?
Yeah, like the Revit benchmark, like you saw, you know, the Raptor, which is our most expensive unit, scored slower than the Striker, and that's just specifically because Revit's not using all 18 cores.
Right.
The Striker at 5 gigahertz just beat it by a few seconds, which, you know, makes a big difference.
Right. Well, let's talk about those specs real quick, just so people have sort of an apples to apples understanding. The Striker itself has which processor?
The Striker is based off of Intel's more like consumer chipset, the Z390 currently. So
Z390,
we're offering that. We're offering that with the i7 9700K. It's an 8-core CPU, and then we're also offering it with the i9 9900K, which is 8 cores, 16 threads.
Okay, and then so which Buck? Do you recall which one I got, or Josh?
You have. He's running an 8086, which is with the D-Lid is pretty much a 9900K. It's not quite the same thing, right, Anthony? I mean, as far as for Revit's purposes, you're going to see a similar score.
To be more accurately, the 8086K is based off of the 8700K. It's a 6-core, 12-thread CPU. Still great for Revit. The 9700K at 8 cores, 8 threads at 5 gigahertz versus the 8086K at 5 gigahertz, they basically benchmark identical. They're within like a second or two of each other.
Okay.
So
that particular workstation had that 8086 in it, delidded, right? I think you said with liquid cooling. It has 128 gig of RAM, I believe.
In that one, you have
that's
I think
the Raptor.
32. Yeah, no.
I'm
On
sorry.
the Striker, it's got 32 gig.
Yeah.
The Striker's 32 gig. Okay, and it had which graphics card? I forgot now.
It's got a 2080 Ti.
2080 Ti. Okay.
Or 2080. Excuse me, 2080.
2080. That thing was ridiculous fast. Okay, it scored 78 in its model. So the Raptor, the other side of that, because the Striker that we just talked about, that one's effectively tuned for Revit, and it proves it. The other one, the Raptor, which processor was in that one again?
It's got a 7940X 14 core.
Yeah, that's correct. And then what we've done, we've changed the overclock on that, so I could elaborate on that when you get to that. But go ahead. I don't mean to interrupt though, Shawn.
No, it's okay. So it's got that processor. It's got 128 gig of RAM, and it's got which graphics card? And that one thing was a beast. It was gorgeous.
That for sure has a RTX 2080.
Okay. So it outperforms in a lot of other things. I know right now Josh is over there testing it out, and he's doing stuff like Enscape, and it's almost instantaneous renders in Enscape. You know, he'll modify the model, change his viewpoint, Enscape, instantly ready to go. I mean, it's fast. He's not waiting a few seconds for it. It's just ridiculous quick. So it's more of an all-around computer, and just like we talked about last week, you're tuning the workstation to the task you're doing. The Striker, with its tune towards Revit, if you're doing Revit modeling all day long, beautiful computer for that. The other one, the Raptor, built for more of an all-around machine. And the processors
the
are different there
Raptor,
too.
Yeah, so you're getting 14 cores or 28 threads, and that's more for something where you're doing a lot of parallel workflows or multitasking. You could be doing many lightly threaded tasks with that CPU. The downside is with the Striker, because there's less cores, we could push that to 5 gigahertz no problem, all cores.
Right.
Whereas the Raptors, We're being conservative right now, but we're looking to try to push this number a little higher. But we change it to like 4.5 gigahertz for 6-core workloads, and then we drop it down from there, where your minimum is 4 gigahertz on all 14 cores, which is higher than Intel. It's like we're basically completely changing the whole boost table that Intel ships them with.
To be clear, though,
and Shawn,
people sometimes when they hear you talk about this overclocking thing, they're like, "Oh, this is unstable. Oh, this is gonna, kill the life cycle of this thing." You guys stress test the snot out of these things.
Correct.
Right? So
the
it's
CPUs
not like
go through a thorough.
just hacking this together.
Right. The CPUs go through a thorough stress testing. The RAM and CPU cache gets tested independently, and then we run a stress test that basically does everything all at the same time, just to make sure there's nothing that got through the cracks, as well as checking temperatures while all of this is happening.
And Shawn, one thing to point. Okay, yeah, you got it.
One thing that's tricky, it's a lot easier to stress test an overclock that has all cores locked at the same frequency.
Right.
Stress testing the Raptors is a little trickier because if you're applying a load across all cores, you're never going to test the boost clock. So we really got to be careful with what stress tests we use in order to test the CPU under all load conditions.
Right, exactly.
Well, and Shawn, just to point out, I think there's a misconception that if you have a 9900K in your system, it's going to perform like every other 9900K. And I think there's also a misconception that Intel just hits print and processors come out. To touch on the 8086 being in the 8700K family, Intel batches these processors. The process of making them, they're not all made equally. They don't come out of the oven. If you make 100 cakes with the same recipe, they're going to be slightly different variances of where they were, what the silicone was, all that. So, if you look, a great example, what Anthony was talking about, the 9900K, if we look at that processor page, it's got a max turbo frequency of 5 gigahertz, but a base frequency of 3.6. Yeah, let's do this. Right there where it says, 3.6 gigahertz and 5, that's a big difference in performance. So depending upon how you gel that together, really, are you going to get 5 or are you going to get 3.6? But that, in RFO benchmark terms, is the difference between maybe a 78 and a 136, maybe 140 even.
Yep.
So, same processor, not built right. And I was thinking about this weekend. It drives me crazy because we get a lot of people that say, well, this system is spec the same as yours. Why is it not performing as well? We all work in companies where we bid for projects. An owner sends us a spec sheet. We have to bid on that. And if everyone could assemble these same parts together in the same format and it always came out okay, everyone would go with a bid, right? But there's a knowledge base on assembling the systems and knowing how they come together and tuning them properly that makes the difference between a 3.6 and a 5. And Anthony, you've driven a lot of that for us. So, touching base on that, I'd love to hear what your thoughts are.
Yeah, that actually even enters into the conversation of Xeon versus, the I family. It all comes down to silicon quality. These are manufactured, they come out as discs, and actually your best overclockers are the ones that are closest to the center. The ones that don't do so good, that don't overclock very well, are actually most likely the ones that were on the outside of the disc during the manufacturing process. Xeons, there's a binning process. Xeons technically have the best bins, and then they go down from there, except Xeons are locked. They don't let you change the clock speeds or anything. And then the hierarchy currently with the current generation on Intel, 9900K is their top of the line, their best binned consumer line, which is actually shared with the Xeon family. But the i7 9700K is a 9900K that didn't pass quality control. So there's a little bit of that goes on.
Good to know. Okay.
Sometimes
still a great processor, though.
Sure.
It's still great, but they disable the hyperthreading. Maybe one core crashed and didn't pass quality control, so then now it just becomes an i7. The other thing that comes into play too is, sometimes demand will on the i7s will be higher than the i9s. So you'll get some i7s that should have been i9s. And those
Sure.
tend to be the really good overclockers. Like, you know, that's when you start seeing 5.3 gigahertz, 5.2 gigahertz at really low voltages on an i7.
Now,
The
Anthony, if
best
I was
though,
going to go out and build myself a computer today, how would I know that I got an i7 that was supposed to be an i9? Would I know that as a consumer?
it's the lottery, man. It's called the
Right.
Silicon Lottery. Yeah, it's just the way it is. It's like go buy a lotto ticket. That'll determine how good you overclock. So, you know, CPUs that don't meet our standards don't make it into the system. That's another factor as well.
Sure.
There's one web page if you're an enthusiast or you're an architect and you just money's tight and you got to build your own and you don't want to deal with binning or whatever. There's a web page called Silicon Lottery, and they pre-bin and sell CPUs. What's fun is sometimes they provide statistics on their findings, like only 10% or less did 5.2 gigahertz or whatnot. So if you're just an enthusiast or you're an architect and you got to build your own system, this helps because they're actually telling you the voltages they use to achieve their overclocks.
Nice.
And that'll eliminate a lot of the work for someone that's not so familiar with overclocking.
Fantastic.
The biggest mistake people make though is they don't stress test.
Right.
And
Yeah,
Shawn, just to answer, if you took it out of the box, you would have a hard time knowing if you got gold or not. I mean, literally,
Right.
you know, and that's one of the things that I think Anthony's gotten, I don't know, down about sometimes. We get a CPU for a large order of, you know, 10 or 15 computers, and it's a 5.3, 5.4 processor. We still, you know, commit to the standard of 5 gigahertz. Otherwise, every processor, every computer would be completely different.
Right.
But, you know, unless you knew, because that's one of the things on the overclock, Anthony, is sometimes they say it'll go 5.4 gigahertz at 1.4 volts, you know, or 1.44 volts. And for us, for a 3-year warranty, that's probably not in the acceptable range that we're going to send out a system to a client. Anthony, am I right? Or
yeah.
can you?
No, yeah. Our wall is 1.4 volts. So we ensure these things will last a long time. Some things that used to be that still are circulated today, like overclocking is gonna destroy a system. I'm like, no. I mean, overclocking a CPU, like Buck just said, you know, we ship them all at 5 gigahertz, and there's some that are 5.3 that get through the loop. Intel's doing the same thing. They know every CPU they manufacture is going to do at least 3.8. There's some in there, the ones that are closest to the center, they'll do much higher clock speeds, but so they're not throwing or creating more SKUs than they need to. They're just going to ship them all at the same speed. So overclocking is we're just really getting the most potential out of the CPU that's inherently already built into it.
You're boring out the cylinders and you're polishing and porting the vents.
Right.
I mean, that's you're just tuning the system. That's
Yeah.
all you're doing. So this is again where we go back to the conversation, like an equally spec computer. I've got X, Y, and Z in my computer, and you guys have X, Y, and Z nominally in yours. They don't perform the same because you're hyper tuning everything. You're stress testing it to make sure it's going to work in the long term, as opposed to just throwing it together and shipping it.
Yeah, and as we mentioned earlier, cooling affects how like if you even have an out of the box Intel processor, and you slap on the stock cooler, you're gonna not run as good as a CPU that has a better cooler because you're not gonna leverage the Intel boost clock speeds they advertise.
Right.
So with our lower end,
cool enough to use that.
Yeah, and I don't want to say lower end, but our a new entry level model we're developing right now. I'm hoping Buck keeps his word and we don't overclock this, but it's gonna work. It's gonna work in the best case scenario that Intel intended it to, because it's still gonna be a liquid cooled CPU. So cooling is just as important when you're shopping CPUs specifically.
Right. Yeah, that stock heatsink just doesn't have heat dissipation to be able to handle what they're advertising. They're selling you a processor, not selling you a heatsink.
Yeah, and finally Intel actually stopped selling their K SKUs with heat sinks. A couple of years ago, they'd still send you their rinky-dink stock cooler with it, and
Right.
I would argue that thing can barely. I mean, I don't. They should just stop shipping them with coolers because it's a crime to use any Intel processor with a shipped cooler.
Right.
Well,
So we talked about.
Intel.
Go ahead.
Oh, I was going to say, when you look at that spec sheet on the 9900K, Intel is very conservative in some places and not so much on the other. I know that we're going to get into some memory controller, but when they start looking at memory specifications and it says DDR4 2666, they're talking about kind of what that system is made to run on. Right there, we put a higher speed RAM in, and one thing that the overclocking does as well is it helps the chip's internal memory controller speed up as well. So if you're not overclocking and you're putting faster RAM in, you don't see as big of a benefit of that higher speed RAM than if you're overclocking. So that's another area. It all kind of comes together. It's all symbiotic, but that's another thing that we look at as well.
Absolutely, absolutely. And the motherboard has to be matched to all that too, I imagine.
Right. So here's another thing. You'll see. I'm sorry. Go ahead, Shawn.
No, please go ahead, Anthony.
So one thing you'll see. I mean, I think it's obvious. I'm doing this off my phone, but I think Buck said the base clock speed is advertised as 3.8 gigahertz. Was that correct?
3.6.
3.6.
Okay. So that's actually under, like, I think Intel says that's for like a 90 degree or 100 degree Celsius workload. It's out of the box factory setting is actually 4 gigahertz on all cores for that processor. It might be 4.3. I haven't ran these stock in a long time, so so it's even higher than what Intel advertises. That's how conservative they are.
Sure.
And that applies even to like the 18 core processors, where I think a base frequency is something like 2.8 gigahertz, and I'm like, dude, this thing will never be at 2.8 gigahertz unless you're like at 100 degrees Celsius.
Right. As long as you got proper cooling, it'll stay above that speed.
Yeah, and the other thing too, Intel is perfectly fine running these things at 100 degrees Celsius, but you just don't leverage all the performance that it's built into the CPU. And then overclocking, we're at most in the 80 degrees Celsius range, so we're still well below Intel's quote-unquote safe max operating temperature.
Right. So let's move on to another
usually
topic.
The strike. Go ahead. Yeah, absolutely.
Yeah. So we've talked about the manufacturer a bit. We've talked about the models, the architecture. We talked about the cores to some degree. Anthony, I noticed you use the term cores and threads interchangeably, sort of. But what, threads are twice the count of cores, if I understand correctly?
Yeah. So your cores are the actual physical cores on the CPU, and then hyperthreading. AMD has a terminology for it as well, but basically hyperthreading, it's like creating a virtual core. So the actual CPU itself, its own physical core, can multitask.
Right.
Because sometimes programs will park themselves on a core, and rather than have that core be useless, hyperthreading allows it to still work, essentially.
Sure. So we talked clock speed. What about the cache? You hear about cache a lot, or the memory, right? That's the same thing.
Yeah. I don't want people to put too much thought into this because it's not like there's a chat box where, oh, this 9900K has 12 megs of cache and the other one has less. Intel doesn't let us shop that way, but you could look at it this way. The more cache, the better, just because it's hyper fast. Right. It's way faster than your RAM. And ideally, you want as many things sitting on your cache as possible, because if it can't fit in the cache, it's going to go to your RAM.
Right.
So
and that's a bottleneck. When it has to transition across the motherboard to go from processor to RAM, and if it's already in the processor's cache, it's ready and accessible faster.
So the realistic way anyone would shop cache is like I could afford an i9 and I could afford an i7. Maybe I'll get the i9 because there's more cache. That's kind of your only realistic way to shop on cache, but it does help. I mean, especially on single single-threaded processors, if we get an i9 and disable hyperthreading, and you put that i9 against an i7, so now they're both at 8 cores, the i9 is going to be faster just because it has more cache.
Right.
But it'd be silly to buy an i9 and disable hyperthreading just because, you know, you want a higher clock speed of 100 or 200 megahertz.
Right.
Hyperthreading's still worth it.
Right.
Well, to chime in on that, Anthony, we've been doing some testing this week just on the hyperthreading and cache. So Shawn, one of the things, just to chime in, and this is not really relevant for most people. This is when you're really trying to beat Anthony's score of like 72, which I often try to do and very rarely can. When you look at the hyperthreading, if you go back to that page, 16 megabytes, on cache on the CPU is 16 megabytes of smart cache. That's spread over 16 threads. One of the things you can do is disable hyperthreading. So now instead of having 1 megabyte of smart cache, each core has 2 megabytes of smart cache. So we've been doing some testing this week. I've seen an improvement, and I definitely have on my RFO benchmark, 2 or 3 seconds, so like a 78 to a 76, which for me is a win. It's still not beating Anthony's score, so I'm furious. But it's interesting to look at how all this stuff plays, you know, really getting down to the minutia of how fast can you feed it. And one of the reasons we have an article I shared with you yesterday is, you know, your CPU can process so fast, it's almost, there's a lag. How fast can you get data to it to crunch? So by giving it more cache, more data ready to crunch, it does. So this is the instance where, while we love our high core count Raptors, you know, we honestly, an i9 with a disabled hyperthreading is a faster computer, right? So this is really relationship. Yep.
Right. So that's awesome. Okay.
The people that get to shop these decisions on how much cache they want, it's like Google, essentially, when they're speccing a data center. There's some Xeons out there that will have really large amounts of cache, and despite they might have less cores, because of that cache, we're talking like $12,000 CPUs. You know, so, but, you know, for our realistic purposes, faster or more cache is better, but we're really limited on how we could shop that.
Right.
And then if AMD has more cache, their cores are so much slower, it doesn't help you anyways.
Yep.
So there's that to consider.
Absolutely.
And we're a couple years off. We've looked into, Kelly Cohn actually got us into looking at getting our own processors manufactured, and the volume you have to buy, we're not quite there yet, but I think in the next 3-4 years, you're probably going to see me and Anthony sitting in a lab somewhere trying to figure out how to get as much cache as possible on like 8 cores.
Right.
Yeah, I didn't realize it. Like, Buck actually sent me a link, and I'm like, oh, you can order your own CPU. Like, it's not cheap, though.
No, not at all.
Nice.
So, were there any other topics? Cache.
I didn't have anything else on my list. Did you guys have anything else on your list?
Well, I did. I kind of wanted to get Anthony to touch on, you know, Xeons for workstations, and I would be pressed to say the difference between an i7, i9, and a Xeon. Well, you say iCore would be their consumer grade products, and the Xeon is historically, Xeon was a 9-bit processor, which has an error correcting. That comes with a slight hit in performance in that ECC RAM, error correcting RAM, 9-bit RAM is extremely slow. They don't make high speed error correcting RAM. And what that means is,
to interrupt real quick, isn't that because the Xeon is slightly more tuned for like a server style?
It is. It's kind of built to be bulletproof, you'd say, but you still get crashes. You still get blue screens. Sure. One of the things when they're binning them is that it can last a lot longer. And Anthony, you correct me if I'm wrong. A lot of the longevity of that is a 4 or 5 year lifespan for a processor if it's going to be in a server. But most of our clients, we're talking 2 or 3 year cycles. So additionally, the manufacturing process historically wasn't great, and now it's getting a lot better. I mean, it's standardized. Xeons aren't that much different. Like he said, you're seeing 9900Ks that are in the same family, and meaning that they're made on that same piece of silicone. They just don't have the quality that a Xeon would. But for AEC purposes, I would take a 9900K that's considered a lower quality Xeon where we can tune it than I would a Xeon that's considered a higher quality that can't be tuned.
See, and that's the key factor there again, right? Because the Xeon, what you buy is what you get. Whereas if you're buying the i9, i7 series, i5 series even, you have some control over the overclocking and the tuning of that the Xeon just doesn't give you.
Yeah, basically, the Xeon is Intel's, most premium quality, but they do this, like NVIDIA will do this with Quadros. They get their most premium quality, and then they run it at slower speeds so that in case it's at 100% load 24/7, it'll still like guaranteed outlast their warranty period. Right. But realistically, a CPU might last, like mechanically last over 20 years. I mean, and then if you overclock it, maybe you cut that 20-year number down to 15 years. No one's going to be using their computer that long.
No,
I mean if you're making money with it, yeah, they'll be obsolete in 5 years. And I'm like, and hopefully your upgrade cycle is 3 to 4 years, realistically.
Right.
But so that, I mean, that's the Xeons are more like Intel's like worst case scenario. You do get the ECC RAM, but I would argue no one but a data center needs ECC RAM anymore. What that does, it's basically you're now limited to 2666 megahertz as of today. ECC RAM will run at 2666 on a lot of the Xeons, and it's still slower than consumer 2666 megahertz because it's actually double writing. It's writing the information twice. I'm just trying to like put this in simple terms, but you're not doing yourself a favor getting a Xeon. If you're super paranoid about stability, just get an i7 or an i9 and don't overclock your RAM, and you'll literally have the same stability as a Xeon, and you're saving money.
Yeah.
I mean, there's just only data centers need Xeons, especially now with consumer i9s, hitting 18 cores. You would need a Xeon if you want to run 2 CPUs because you need a specific CPU that can do that. But I mean, for most practical uses, I mean, I don't know. And Intel, I think, is getting wise to this because, last year they've introduced some Xeons that have the same clock speeds as their, i7 counterparts, which, says a lot that I'm like, oh, finally Intel's starting to realize this. But you still can't overclock it and you're still stuck with slower RAM.
Right.
So
what you buy is what you get. It's not customizable. You're like buying an Apple.
Right, exactly. Exactly.
To talk about buying, Shawn, to go back to my sales hat on from the day I used to sell, when we say it's the best processor Intel has, when you walk into a room to talk to someone or try to sell someone, the old famous sell me a pin. If I walked in and I said, well, I was selling a car, this car is lightning fast. It has 2 doors, 2 seats, all this. What if I'm trying to buy a truck? What if I need to hauling capacity? All the things that you just sold me on value make no sense to me, right? There's no value on my end. And I think that's really where we try to be mindful. And that's where the application specific aspect of it comes in of this is like, when Josh was talking to us, he goes, man, this Raptor is amazing. I can't wait to put it through a Revit test. And I was like, no. You want the Striker. That's the one for you. And he's like, but it's the Raptor. It's got this B CPU in there. It looks right. Amazing. And, in all intents and purposes, that's one of the reasons that I think Anthony has argued with me about putting a different case for our Raptor and our Striker. We'll have clients that buy a Raptor and then we send them a Striker and they're like, it looks the exact same. It might be, but the use case is the important part. And I think that's a parallel to a lot of computers.
It looks different when you pull the sides off.
It does. Yeah. We don't do the glass windows anymore, which
and to be fair, guys, if you buy a BIMBOX and you get it and you buy that tower, pull the sides off, man. Anthony does beautiful work. That thing was gorgeous.
Oh, thanks, man.
Yeah,
Yeah, cable
but
management is one of my favorite things to do.
Right.
well, and one thing to talk about, John, because I think this will get into a cool topic, is the TikTok method. Computer dies have been getting smaller and smaller, and it gets down to this where quantum computing comes in, right? We can only shrink the distance between 2 points so far until it's honestly non-existent. So there is a day coming where we will have to transition from a silicone-based processor to something faster. And right now, I mean, we're seeing really, really, really fast clock speeds. We have 14 nanometer dies. It can only go so far down. So when we talk 15 years out on a processor, I don't know if a processor is going to be the same thing we're talking about today. I know that's the futurist in me coming out. I think quantum computing is forever down the road, and I have some friends that are actually working in the college area that's on quantum computing. But that is where you don't actually have silicone. You're checking the state of a molecule that's changing. And it's really exciting when you get into that. But right now we are limited to what we have. Anthony, do you see 8 gigahertz processors coming out in the next 2 years? I know we always kind of get questions
No.
of, should I hold off on buying a new one?
No.
Is there a new processor coming out?
No, absolutely not. And if we look back in recent history, the gains haven't been huge. We're going from 4.5 gigahertz, maybe with Skylake, to now we're at 5 to maybe 5.2 gigahertz. What Intel started to do is add cores. I think they're realizing, we can only go so fast. So now everyone's just starting to add cores. Now we're having that cores war that we had in the 90s. So it's kind of interesting how marketing teams find other ways to sell CPUs, I guess.
Right.
I mean, man, 32 cores in a consumer level CPU is kind of crazy, but it's good for us because now we could overclock them.
Right.
Yeah. Well, and we get that call a lot. I want to go back to the AMD thing because I know that a lot of people know I think it's a bad word. I got a call last week and someone said, "Hey, will you build me a 36 core AMD processor for point cloud processing?" And you have to ask them because we know how the algorithms run at Leica and Faro and a couple other places. How many scans do you typically process? And he's like 10. And right now, with seeing the new beta that they're coming out with, each scan gets a core. So unless you're doing 36 or 64 scans at once, you're getting a slower clock speed and you have a lot more resources available as you process, but absolutely no gain over a 14 core Intel if you're only doing 10 scans. We might see a little bit of that, but I think that once again, that's one of the great things about AEC is while this war for cores is going on, right now you're seeing some of the best processors out there for Revit, for CAD, for the things that we do. I mean, they're right here, they're right now. And it's exciting. I mean, I think, Anthony, when I had my first 7700K, I got it to 5 gigahertz and it was cold, man. I had a huge radiator on it. But, the score was pretty much the same 3 years ago for RFO benchmark as it is today. So, you don't have to wait on something coming down the pipeline. These processors have been out, these speeds have been attainable. Now we're at 8 cores as opposed to 4 cores. But like I said, my RFO benchmark score has not changed dramatically. It's under 80. We have yet to break 70.
Yep.
Yeah, it's just the core counts have gone up. Sometimes generationally, you'll see the instructions per clock or instructions per cycle get better, meaning that's when you start seeing, 5 gigahertz on this CPU is faster than 5 gigahertz on that one. That hasn't really happened for maybe about 3 generations now on Intel. So they've been adding the cores and adding some cache, but I'm not really seeing any huge leaps and bounds in the next 2-3 years, 4 years maybe. And the thing is, if you're always waiting for the next thing to release, you'll never stop waiting. I mean,
there's
something's always coming out.
Right.
Yeah, literally.
Well, and right now it seems we're at the stage where software needs to step up. For so long, no one has really had anything other than Dell or Lenovo or HP. So why write your software more efficient than most people that have 6 to 8 cores? Now that you're seeing all these higher core counts come out in consumer products at a much lower price point, you're seeing software companies play catch up and start to make it for dual GPU or higher core counts and algorithms. And it makes sense because, you know, hardware on some of these things, drones came out. Now we can get 2,000 pictures in 30 minutes, and now we want to process them all. Or laser scanners. Now you have the BLK that can create massive amounts of data in less than an hour, but how do you crunch it? You know, and now that these computers are out there, there's going to be kind of a lull while software companies try to play catch up. And it's kind of an interesting place to be. I mean, from the hardware side, it's a little frustrating knowing that at some point Intel is going to slow down again until AMD comes out. But we are at the stage where software companies are starting to be, you know, starting to go back to the drawing board of their algorithms or processing.
Right.
You know, I know that Inkscape, and we've seen it on GPUs, where the first thing most of these real-time rendering companies do is try to get the program or the rendering off the computer and onto the graphics card. Inkscape's a great program to talk about. Once you load up your scene, it's running on the GPU. So, you know, the CPU is not important. Not at all. You have that initial rendering where it's being sent to the processor, but it's all graphics cards after that. And that's going to be the GPU processor, which is lightning fast. And we for a while, a couple of years ago, were messing around with mini-core technology. Intel had created a co-processor, which was the Xeon Phi series, which would have up to 256 cores per, it looks like a graphics card. But the problem there was you had to design your software to be able to be broken up into 256 threads,
right,
and very few processes. I mean, when we started talking to developers about, you know, hey, can you do this for floor flatness, or can you do this for real-time, you know, laser scanning? They can, but, you know, you're talking about a couple $100,000, a couple years development to do that. I mean, that right now, they're using that technology for maximizing efficiency in traffic lights over the course of a city based off satellite imagery. And that's a great use case for that. I mean, we talked to this guy, he had 4 Xeon systems working as the masters for 36 co-processors, something like 4,000 threads. And to write the code that was optimized for that, he was getting down to the machine level of coding for how long a process takes to process. Because if you had it broken out and it was crunched, it still had to send the data back to a processor. And where was that processor in the thought process of the program? So you know, it's going to kind of be a back and forth between processors and software. But I think right now the ball's in the court of the software programs.
I think so too. I mean, Revit right now.
Completely agree.
Revit is a big example. It's still primarily a single core computer or a single core program. AutoCAD is still primarily, if I remember correctly, a single core program. And those are the 2 most popular design programs out there, at least in the US, for Revit work and for building work and for civil work. And vast majority of many of our work days is spent in those apps. And there's some of us who get the fun of being able to be in Enscape or we're out doing point scans, but that's not the majority of people. The majority of us are using single-threaded processes all day long, and we're limited by that. Revit's
I think Revit has a bulletin on a few tasks that'll use more than 1 core.
Correct.
But I mean, it's like it's just silly. Like, man, I mean, I think it's just a lot of the software across the board just needs to be rewritten, and it's a huge investment on time and money, really.
Yep.
Well, and right now,
on our side, it's been very frustrating when we have to write against Revit as a single-threaded tool set as well. We're trying to find ways of breaking our add-ins inside of Revit and in AutoCAD off to a separate thread, and sometimes Revit pukes all over the place because it's so purpose-built for single threading, and that's a huge bottleneck.
Yeah.
Well, and you know, in fairness to Autodesk, if I were them right now you can buy a 9900K, put it in a computer with really fast RAM, and you can have a good experience. I don't know if I would rewrite Revit to run on cores, because at some point, how fast can your drafter draft? I mean, how fast can, and I think the plugins, as you said, it is the only place you really hit that. We have clients that do simulations, lighting analysis, and this, that, and the other. Dynamo even, it has to interact with Revit, and that's when it hits the single core. But a lot of that stuff you can do either off, you know, outside of that. And for the people that are using your plugins, which wonderful plugins, I used them when I was at Balfour Beatty. It's not a big enough group to have them spend, 3 or 4 years going back to the drawing board to redo a product to leverage multi-cores when you can have a really good experience if you have the right hardware.
However, I'm gonna disagree with you a little bit, Buck.
Okay, I like that.
Mahler is one of the individuals that we both know who works on some fairly large models. Right now,
he does.
Him and a number of other individuals, another large companies, for them to be able to work on their real projects, they have to subdivide their models because Revit itself cannot handle it. It can't load in, the processor can't chunk through a 6 gig model. So we have to make 6 1 gig models or less, right? That's a limitation. That's not practicing true BIM. Civil 3D, huge sites. And you have to subdivide into a small area compared to the whole area you're trying to work on. You have to subdivide that, split that out. You have to have an add-in to break that apart because it can't handle the entire 17-mile freeway in some cases. It pukes all over the place. And that's, again, I think in large part due, one, to programming, just bad code in some cases. But secondly, it's only using one processor. You can't take all that information and spread it apart right now. And that's a huge limitation. So we're getting by, right? You can get a fast processor and you can get by, but for them to really make a true building information modeling tool set, we need to be able to handle a building. All disciplines, not that people would do this, but let's just, for argument's sake, all disciplines, one building, huge models, say a 50, 60 gig model. Can't do it. It's not possible right now.
No. You're right. And I was doing a ton of InfoWorks modeling, and it always frustrated me that I couldn't see more than a certain amount, just exactly what you're saying, of square footage. And in many instances, like I know with Autodesk Recap, they limit the number of points that you can actually see in any given view because they're worried if your computer didn't meet the hardware recommendations, it would crash, right? If you try to show 15 million points in real time rendered out, it would be a horrible experience. So I think as much as I would love to say it is on them, we all woke up a couple years ago when virtual reality came out and decided all of a sudden we need a fast computer. So Autodesk is, in their fairness, we have not always had great computers to run their programs on. So, I think you're right. There's a give and take. I do love where they're going with their Esri partnership and other programs, but I think that raises the question, what is BIM going to look like in the future? What's the environment going to look like in the future? Is it going to leverage GIS? Are you going to be able to pull in your civil to your information model to see multiple buildings and models? So I will tell you, Aaron is one of the most difficult and fun-friendly characters we have. I was talking with him this morning a little bit. He does put things through the rigor, and I tell you, he's one of those people who constantly plays devil's advocate. When I say, you don't need that much, or why would we do that? He constantly throws back at me, same situation you just did. What if I'm trying to do this, that, and the other, and I want to see everything at once? I'm like,
right.
If maybe 20% of our industry does BIM well, right? This is one of our opportunities at BIMBOX. If only 20% of industry is really leveraging BIM and doing these advanced things, we have an 80% growth rate. At the same time, 80% of people out there aren't experiencing this problem, and that's 80% of a small niche group of people as is. So how big of a problem is it to a company like Dell or Autodesk? Just to throw it out there from the business side, I don't know how big of a problem they view that.
Right. Just to kind of jump in on this conversation, I see Kurt and Robert out there making comments on this. Robert was saying that he's got 500 meg limits on their models. That's where they cap it because they can't go bigger or it becomes too slow. I see that problem a lot. And that's partly due to hardware, but again, it's in large part due to Revit. Kurt Johnson was saying he's using a federated model. So what that means is they're taking multiple models and linking them all together to federate this, or to have some bits and pieces and parts all over the place, but then they got one main model where they're doing a lot of their documentation. That's what a lot of people mean with that. So that, again, it's all due to limitations of Revit being single core. So I'd love to see the software people step up. Autodesk, if you're listening, you're probably not, but if you are, come on, guys.
I'm just going to challenge this. We've had several multi-gig models pulled up, and it's a good experience. So before we go say nay on the software, I would just say check what's in the box sitting next to you that's connected to your monitor.
That's true. If you really want to test this out and try and push the limits, BIMBOX makes some really fantastic tool sets, fantastic workstations. Man, it's great. if you want to know more about refining it, talk to whoever your reseller is. If you want to get our tools to help you further refine your models, you can talk to, in the United States, it's ATG. In Canada, if you're listening to us from Canada, it's going to be SolidCAD. They can get you access to the tools to try this stuff out, and you can clean your models up, make them nice and neat. Because a big thing, if you're talking about these models, if you don't keep your data clean, you don't, clean up after yourself. It's like erasing your sheet of paper, right? You want to make sure it's nice and clean, not a bunch of garbage on there. So keep it clean, get good hardware. You're going to have the best possible experience, and then let's see where those limits are. But I think you're still going to run into, if you're dealing with the large models, you're still going to run into issues with single threading.
You will run it.
All right. Rob, do I really think Autodesk is listening? No, I think they probably ignore me and tune me out, but that's that. We'll see if they ever comment back to me on something. Okay. We're way past, well, not way past the hour, we're on the hour. Last week, Buck, I picked the drawing for the end of this whole series, what the criteria was for this week's entry. Why don't you pick this week's criteria for the BIMBOX workstation drawing and the CTC software drawing? What's the question we're going to have them answer for us this coming week?
I'm trying to think about that. I was about to say, if someone could send me some of their big files, but once again, these are probably classified, can't share. I wanted to see what's the biggest model you've ever worked on. How about something like that? What's the biggest model you could put on your computer? And if that means linking in a ton of files, just let us know, where you ran into system instability. Is it a 1 gig model? Is it we said 500 megabytes. What happens when you get to 750? Just kind of shares that crash.
Right.
And whatnot. I don't know, Shawn. I'm going to opt out to you if you think that one's decent.
I think it's a fantastic one. Let's get some chatter on that. So in the comment section down below on this video, either in the live session, which we're capturing, Kurt Johnston says, whoever has the largest BIMBOX order. No. BIMBOXes. We're trying to give some away.
Right.
Still, you're entered to the drawing too, Kurt. So in the comment section down below and in the live feed, if you're live today, send us what that is, your largest model that you've worked on in Revit, successfully or otherwise, and some of the information behind that if you can share it. That'll get you entered for this week's drawing on this video once it's up on YouTube there.
What are we going to do for this week's drawing? I have an idea, but I haven't run it past you, so I don't know if it's worth bringing it out.
So what I was planning on doing, just to kind of clarify this from last week, you gave away that drive from the first week, and that's being announced in our next BIM broadcast session, that drive right there. We're going to give that away next week from the comments that we got, the direct messages through Twitter. That was, what was it, the single factor, the most important thing that drives your computer's performance. That's what the question was, I believe. You direct message us the answer for that, and you're entered to win that drive. That, again, is getting closed out very shortly here and drawn the next session. What I was planning on doing, Buck, was accumulating these answers throughout the rest of the series, and that's when we're going to give away the BIMBOX at the end, the BIMBOX workstation, and the CTC Software Project Suite license. If you want to do something every single week, we could certainly do that, but what I was planning on doing was the one big drawing at the end. Your call.
I wanted to sweeten the deal up, man. I think we got some good folks that are listening in, and we actually just pulled several demo mobile workstations, laptops out of commission for no other reason than we have a new series coming. So I have a 15-inch Slim with a 1070 in it, mobile processor, 32 gigs of RAM that I was going to say might be this week's or next week's. If you want to do a 2-week roll for people that listen, maybe we do the next 2 episodes.
Let's do a 2-week roll on that one.
Yeah, well, that will be it. If you want to win a BIMBOX Slim laptop VR ready that is lightning fast, I am happy to put that up for this.
Okay, so session 2, part 2, and part 3 is going to be that particular drawing, that slim 15-inch laptop VR ready. So the question this the thing this one for the comments in this video's feed is going to be your largest model that you've worked on successfully or otherwise, and if it crashed, what led to that crash?
Hey guys, real quick, I need to get off the call. You know, we're out here, gotta get going.
Understood, Anthony. Thank you so much for your guys' time. In fact, we got to end the call. We're way over an hour now, so thank you both for your time. We look forward to seeing everybody else in future BIM broadcasts. Sign up, subscribe to the channel. Make sure you're liking videos. That gives us you know, better visibility, and we look forward to seeing you all soon.
Cool. I'll see you guys.
See ya.
Awesome. For the Disneyland.
Yeah, right.